process to
clarify the phenomenon of photoelectric effect. And through all the process, I want our students we have to make sure we're all clear about two main points. The first one is what is the phenomenon of photoelectric effect, and the second one is the condition cause this phenomenon to happen. So to start with the phenomenon, I will describe to all about the very famous experiment of German scientist called Hurt. She used an electroscope, which had the structure like this one. He used a negatively charged zinc plate. And this part of the structure will connect to two other small plates down here, because this system have a negatively charged, so all the plates repels from each other because it's charged the same charge. And then he used an ultraviolet ray to shine on the surface of the plate, and after that, the phenomenon that you can see is two plates get closer to each other like this one. So that means this system will lose the amount, a specific amount of electron. So the phenomenon of photoelectric effects, which is when you shine a light on the surface of the metal, and to cause its electrons escapes from the surface of the metal, and that whole phenomenon of photoelectric effect. Moving on to the second effect of the process, which is to find the condition that cause this phenomenon can happen. I will use experiments to find out the condition. The components of the experiments consist of photoelectric cells. Which component? An anode, which is a ring, and a cathode, which is a piece of metal. These two components are linked with a circuit like this. This one is the resistance change. This one is a variable resistor, and this one is the source of electric. So because surface of metal. So with this improvement, I will try lighting on these particles.
Yep.
So that
Can you track the circuit carefully? So what does the voltmeter measure?
well, when you shine a light on the surface of metal, so all the electron here will be escaped from the surface of metal, so that it can. And when I put an electromotive here, which is create an electric field here, you can cause the electron escape from this one, go through the anode and make and create a current on circuit. So that's when the
And the galvanometer will help to recognize that current.
yes, this galvanometer will recognize the current that appear on circuits.
So whenever we see a value different to 0 in the galvanometers, we can conclude that there's a free electron.
Yes, that's right. And then I will do this one is the real structure of this one. This one is the one can the ammeter that we can measure the current, and this one is the voltage voltmeter. First of all, I will shine a white lighting onto the photoelectric cells, and I will change the resistor to this, so that it can reduce the specific of U here. And on the ammeter, you can see that the value of current is different from 0, so that can make sure that there is a current inside this one, and that's also ensure that the photoelectric effect can happen when you shine a light in. And moving on to the next step, I will do the experiment with different wavelength of the light by using filters, different colors filters. The first filter I will use the red one to put it in here to create the red light, and turn on this one, and also change the value of resistor. And the value of the ammeter that I can place is approximately 1.6 microampere.
It's very small, let's say.
Yes.
So it seems the effect does not happen yet.
Yeah, we can see that the value of ammeter is very small at the scale of microammeter. So it seems like this wavelength is not really effective to the phenomenon can happen. So I will change to another filter is blue one.
and we have to make sure that the filters obstacle all the light coming to the cell.
Yes.
So it means that only one single color light come to the cell. In this case, is a blue one.
Yes. And we can see the value of ammeter is totally different for the first case, which is now 70.9 microammeters. So maybe the wavelength of the blue light is much more effective to the phenomenon in heavens.
Yeah.
And I'll do the experiments for several filters and conclude the condition to make sure the phenomenon in heaven is you have to shine a light which has the wavelength smaller or equal the threshold wavelength, which is the lambda 0 is characterized